Okay, so let's explain some experiments concerning particles that form in the Earth's upper atmosphere and then travel to the Earth and are detected on some or in some detector on the surface of the Earth. So here is the surface of the Earth. Here's the detector. Here's the particle that forms. It travels at some speed v naught, and let's say it barely makes it to the detector before it decays. So it lives a certain amount of time, and so from the fact that it's going at a constant speed, it travels a distance given by v naught times the time that it lives. So from the perspective of an observer on the Earth, it lives some time t Earth, and it travels a distance given by this, which is that distance there. And from the perspective of the observer on the Earth, that distance is, let's say, RE. But from the perspective, now let's take the perspective from the object's frame. And so let's measure things in the object's frame. And we know that this object is traveling. And so the time that it's observed to live from the perspective of the Earth is not the same. In fact, the object must live a time, right? This is the proper time of the object, right? It's going to be less than because of the time dilation factor. So it has to be, right, this is in relation to the speed of light. So this is some fraction of the speed of light. So we get 1 minus v naught squared times TE, and that's less than TE. That's the proper time of the object. So the object lives, if you measure the lifetime of this object in a laboratory, you get the shorter time. So how does it make it to the surface of the Earth from that perspective? Because the physics has to be the same. That's an invariant quantity. The fact that the object was detected in the detector, that's true regardless of the perspective. So let's look at this and let's go through the analysis of the speed times time equals the distance traveled. That must be true from the perspective of the object as well. So the object from a frame that's attached to the object, we can treat that frame as stationary, and from that perspective, it's the Earth that's traveling. It's the surface of the Earth that's traveling toward that object, and it's traveling at the same speed. So we have v naught, but the object lives the proper time, right? So we have a time t naught. That's how long the object has to live. And that distance is v naught times from, right, we'll use this relation. We get, let's bring in let's put the TE in front. We get 1 minus v naught squared. And this is clearly not RE. So what's going on here? Well, from the perspective of a measurement done in the frame that's attached to the object, the distance traveled is different because now the Earth is moving towards the object. And so the distance is actually not RE, but it's length contracted by this factor. So that's the distance traveled. And so we can see that everything makes sense because we have the speed times the proper time is equal to the distance traveled, which is shorter. And therefore, we in fact recover Oops, sorry, this is little r, Ra. So both perspectives give us the same physics.